just small presentation again, what we're doing here. So we're the FHIR meetup group, and we're meeting together to discuss different topics around FHIR. And today we have two, I think, remarkable FHIR implementers to speak about not very standard, I would say, use of FHIR, but very important. So a couple of things. We have community in Telegram. Here is a link on the screen. Please join if you are willing to contribute to the topics around meetup. We definitely don't want to pull people to discuss FHIR topics from chat.phir.org, but like suggestions around organizing, submitting speakers, discussing dates of the meetups. That's what we want to discuss in the Telegram. So please join. Everybody's welcome. Previous FHIR meetup recordings are available at our YouTube channel. Here is a link as well. And yeah, so this one is also going to be recorded and will be posted. So just know about this, and you always can come back and see previous presentations. I want to call for speakers, and I want to say one topic we really want to have presentations about. We want to invite people who developed solutions on top of the FHIR server, using FHIR server as a sole backend. We call this development FHIR first, FHIR native sometimes. So that's something we really want to showcase, and we really want to independent from what FHIR server you use, what kind of backend. But if it's based on FHIR, you use FHIR information models on the backend, we really want to showcase your application. So that's one of the topics we really want to have as a future meetups. Please, if you have some applications like this, send us a message. We want to have you presented. So one thing we always do at this FHIR meetups, we want to discuss what happened between the last FHIR meetup and today's FHIR meetup in the FHIR world. Also ask presenters if they have any news to share. I wrote a couple of things yesterday, just was exploring what happened in the last couple of months. One thing that affected a few of our clients was cancellation of enforcement of peer-to-peer data exchange by CMS. Josh, what do you think about this?
The cancellation of enforcement? For me, this actually underscores the value of consumer-directed data exchange here. That's the pattern that we've had in place the longest when it comes to individuals getting access to explanation of benefits and other data from their insurance providers. And I think that's actually a really good route for sharing data between old providers and new. So having one consistent story, consumer-mediated exchange, is a really positive development for me.
Well, I think, the current rule was, had some problems. From my perspective, they even didn't enforce the standard of exchange, right? And there is a new proposed rule where they enforce FHIR for that, and perhaps it's going to be reintroduced. I kind of support that they cancel the current revision of the rule. But anyway, so that's one of the news. The other news, I think I found that there is a FHIR application competition hosted by EMEA, which I think applications already selected, but the competition itself will be held October 30 to November 3. So that's related to FHIR directly. I know a lot of companies are interested in social determinant of health nowadays, and there was a release of STU1 implementation guide. So I think that's interesting. And the next FHIR Connectathon is January, so not very soon. Any news, Josh, maybe from you are interested in Microsoft, your work?
Yeah, I'll say a major focus for me over the last few months has been the smart health cards effort. So that's a verifiable clinical information, a way to give individuals a copy of something like a COVID vaccine record or a COVID test result, a copy they can take with them and then share downstream with cryptographic signatures on it. So that's been a really fun project because it's seeing very rapid adoption, both in the US and Canada and internationally. And it uses FHIR internally. So when you see these QR codes, once you decode these things and expand them, there's FHIR resources like patients and immunizations inside.
Yeah, I always amazed how projects where Josh participates have great adoption. I mean, like from Smart on FHIR to Async for Science, and this one, I mean, that's pretty cool. And I think adoption is, I mean, very important for any project. Nikolai, any particular news for the last few months?
I don't think I have some important news. Maybe guys who joined us would like to share something.
Any news from companies or like around FHIR, which community can contribute? Anybody?
I had a quick question on that COVID vaccine card or test result. Josh, is the idea that that information would be stored in EHR?
So for the Smart Health Cards initiative in particular, the data could come from a number of places, which is what makes it kind of interesting and challenging. In the US, we have a very decentralized system. So people are getting records, in some cases from their healthcare provider, in some cases from the pharmacy that gave them the shot, in some cases from an insurance provider, in some cases from a state immunization portal. So for example, the state of California was one of the first states to build their own portal, and they open sourced it. And then other states are picking that up as well. So it's really been kind of all of the above.
Right, and the security of that is questionable. If someone knowing a little bit of information about you can get your vaccination status, that could be a good or a bad thing. But is the idea that you would have to, all of them will have a FHIR endpoint for us to get that information, or would it be synchronized to some centralized source?
So, I mean, the idea is these are records that go directly to the consumer, and then the consumer shares them downstream. So we are very carefully not connecting verifiers back up to the health systems. And the goal there is to prevent tracking of individuals and to prevent conversations happening behind somebody's back. So as a user, I get a copy of this record and then I decide when and where to share it rather than connecting other parties together.
Okay, I'm trying to understand where FHIR comes in here. Is it the idea that you'll be communicating with all of these endpoints using FHIR?
So the link that I put in has more details, but very briefly, the actual QR codes themselves use the FHIR data model. So internally, we have things like FHIR immunizations that have the semantics from FHIR. We also have an optional FHIR API that allows you to bring data into a consumer health app. So for example, if you have the Apple Health Records app on your phone, that app may be able to connect to your provider and bring that QR code onto your phone through a FHIR operation.
That's nifty. Thank you.
Any other questions, comments, news from the audience? Please be active. All right, let's move on. So today's, and I feel really bad I didn't fix the title on this slide. So we definitely don't discuss FHIR profiling, which was last time, but we still have 2 presentations and 2+ hours we scheduled for these discussions. So please get your questions ready and ignore the the title on this slide. And not to continue this for long myself, I want to pass the word to the first presenter, Josh Mandel. I think Josh is, I mean, I see 2 people which I really don't need to present when there are FHIR meetups. It's Graham and Josh. But Josh participated in so many visible projects, again, from Smart on FHIR and Async for Science and Smart Health Cards, and he's also now a chief architect with Microsoft. So Josh, please take it from here.
Awesome. I was really excited to come and talk about this topic, mostly because I think it's something we haven't delved into very much as a community. And I want to basically lay out a few use cases, maybe some pain points, and just sort of a design sketch. We really haven't done much work towards standardizing anything here, with one major exception, which is what's called FHIR bulk data access. So I pasted a few links into the Zoom chat, and these are just the web pages that I'm going to be switching back and forth between over the course of the next couple minutes. So let me turn on screen sharing. And I wanted to just start with a quick level set from the perspective of one place where asynchronous operations have really made their way into industry and into FHIR servers. And that is a use case called FHIR bulk data access. This is something that today is part of ONC's regulatory requirements for every certified EHR in the US. Those requirements have not come fully into effect. So EHR systems have until the end of next year to release support for this functionality, but some EHRs do this already. Epic, for example, announced support for FHIR bulk data access a couple months ago. And many of the cloud-based FHIR servers or standalone FHIR servers that work independently of an EHR, many of those servers already support bulk data access as well. So this is a specification that's gone through a couple rounds of HL7 publication and balloting. We've got a new version that's just on the cusp, but I wanted to just very briefly orient folks, if you haven't seen it before. This bulk data access guide basically describes a pattern where you can ask a server to spit out a whole bunch of data. And it's designed to support use cases, a variety of use cases where some kind of consuming entity wants to make sense of a large set of data from a FHIR server. So that could be something like loading the data from an EHR into your favorite population health tool. It could be something like training a machine learning model based on historical data that's been captured inside of an EHR. It could be something like supporting public health surveillance for use cases that don't need to be quite real time. Many different use cases, but the core functionality here is described in these three FHIR operations. One is an operation to export all the resources in a server. And another one is an operation to export all the resources about a specific group of patients. And then finally, a way to export all the resources about all the patients in your server. Those are the three operations that are defined. And so the idea here is, you could call this operation once, and then you're going to get a pile of resources, typically in a new line delimited JSON format. And you just might get like a whole bunch of files as the output of this operation. So if I call the group export operation, I can pass in a format, which is basically servers need to support new line delimited JSON, and that's also the default. So you'll see application FHIR NDJSON. And then there's a few optional parameters like what types of resources do I want to export, and is there a time bound? So I only want to get resources since a certain point in time. And then what we say is the rest of this operation is handled according to the FHIR Asynchronous Request Pattern. And so this is something that's part of the core FHIR spec since R4, but it was really designed around this specific use case. It was put together in bulk data, and we sort of migrated it into the core spec because we thought, yeah, maybe this is actually more generally useful. We know we need it for bulk export, but let's get it into the core spec so other people can use it in other contexts. So I'll just very briefly review what's here because I want to talk about both where it works well, but I also want to talk about some places where I don't think it works that well. And there may be some opportunities to improve what we've written in the core spec. So this is the async.html page of the core FHIR specification, starting with R4. And the idea here is a client calls some kind of operation like bulk export. We call that a kickoff request. So that's a request the client makes that's going to begin some kind of a process that might be slow. The client doesn't know how slow it's going to be, and the server, might not have an accurate estimate either. And so what the server does is it right away responds with a status code like 202 accepted to say, I got your request. I know what you're trying to do. I'm working on it. And then they include a content location header. And this is a way to tell the client, here's where you can go to check on the progress of your request. If something goes wrong, you can include an error right away, but otherwise you just point the client to that content location. And the client can use that in a few ways. If the client decides it wants to abort this request, if it just decides, you know what, I actually don't need these data, it can call delete on that content location. And that's a way to just say, you know, I started the request, but I want to cancel it now. But the more interesting thing that a client would typically do is to take that content location and pull it. So basically just do an HTTP GET to see how the request is coming along, and it'll get back a progress indication. So an HTTP status code saying this is still in progress, and it might also get a header indicating how that progress is coming along, which is just a textual description. And eventually, if the client continues to issue that request and even follows some guidelines for how often to continue checking in, eventually the client will get a JSON file, which we call, I guess, an asynchronous response manifest. And I think we've got an example of one of these, which is maybe easier to look at than just going through all the fields. So eventually the client gets a response like this, if assuming the export has worked, that says, here's the transaction processing time. So if the database underlying this request is doing the request based on a certain snapshot, this is the time of validity for that snapshot. The details of the request are reflected back. And then there's this array of outputs. And these are just URLs to new line delimited JSON files, and they're uniform by type. So the server can create as many output entries as it wants. It can split up the resources across as many pages as it chooses to. But each of these pages or each of these files will have resources of just one type. So in this example, there will be 2 files full of patients and 1 file full of observations. And the client can just go ahead and follow these links and fetch the content and can retrieve, you know, hundreds of thousands or millions of records that have been split across these files. That's the basic pattern that we have in place for bulk data export. And before I share a couple of thoughts about where this works and where there are limitations, let me just pause and see if there are questions or clarifications on what folks have heard so far. All right, I see a note in the discussion around current implementations, one around the permitted group size in the Epic implementation. And yeah, I mean, we're starting to see implementations, and they do have some limits, and figuring out how to work with those or improve them over time, I think is going to be an area of active discussion. When I think about asynchronous use cases in FHIR overall, there's one set of use cases like bulk export where it takes a long time to do. So you might have to wait a while, and it produces a large volume of data. And when both of those things are true, the pattern that we've defined here works pretty well. You pull on an endpoint, and eventually you get this manifest with links to files. But I also think there are use cases where maybe this is not such a good fit, particularly use cases that might take a while to perform, but are only going to produce a little bit of data, or maybe they're not going to produce much data at all. And yet you still want these sort of asynchronous semantics. And in theory, ideally, any operation you could call on a FHIR endpoint, it would be nice if you could call that operation asynchronously, so that FHIR servers could have a path where they manage this kind of processing using something like an underlying queue and task management system. They could pick off jobs from that queue sort of as they saw fit. There are some use cases where that works well. There are some use cases where that might not work so well. But from an API design perspective, it's interesting to think about how you could handle that whole scope. So this document here, this hackmt.io doc, has kind of a sketch about one way to handle that, one way to handle kind of arbitrary FHIR REST API calls. And I put out kind of a call to the FHIR community in the implementers chat a few months back, basically asking about use cases, asking for areas where individuals had some kind of asynchronous use case that they might want to handle in FHIR. And I just made a quick catalog of them here. So, one of them was handling observations that might be submitted by a consumer device, like a blood pressure cuff or a step counter. And the server wants to validate those observations asynchronously, using some kind of a queue processing system, because they might take a while to validate internally, and they don't necessarily want to guarantee a quick response. Another scenario was different trading partners who want to be able to submit transaction bundles, maybe a whole bunch of requests that need to be processed all together as a unit. And handling those transaction bundles could be pretty expensive, especially if those bundles are pretty big. And so it's nice to be able to sort of send off that whole batch of or transaction of requests and then learn about once they've been handled, even if it's going to take a little while. And then there were also some use cases for things like long-running operations, like adding a new search parameter to your server where you need to re-index that server. And then you want to be able to say, okay, we're done. The index is in place. And now searches that use that new search parameter are going to be available. Or they could be things that apply some kind of a machine learning model. Maybe you're running a risk assessment against a set of data, and it's going to take some time in the background as the context of returning that result to the client. So those are a few of the examples that came up from the chat. And what I put together here was kind of one sketch of how arbitrary FHIR API calls might be able to request asynchronous processing. And the idea here, it's maybe worth calling out some of the functionality that we want is, first of all, we want to have really clear separation between the semantics of the asynchronous request. So for example, like, did something fail? I want to make it really clear about whether my request failed or my request went through to the server and the server tried to process it. And then the result of that was a failure. So there's these two levels. One is the asynchronous processing, and one is the, okay, we're handling your request. And it's good to have some clarity about where the status of each of those pieces should sit in this protocol. And in the current bulk data spec, we don't quite have that. Another example would be things like response headers. So in the FHIR HTTP API, we often will respond to a request with additional parameters, things like a location header or an e-tag header that conveys a version, all those kinds of things. And it's nice to have some place to put those headers in the eventual response to an asynchronous call. And we don't have a spot for that in the current bulk data export spec either, honestly, because we didn't need them for that use case. And so it becomes pretty clear that that bulk manifest was designed around a narrow use case that doesn't quite describe all of the use cases. So here's one concept, and I'm by no means standing behind this as like the only or the best way to do it, but just as a design sketch to get folks thinking about this area. The concept would be any FHIR API call that you want to make asynchronously, you just make that FHIR API call, but you include a header that says prefer respond async. So that's how you would kick off that request. So let's imagine we're talking about that first example of posting an observation from a device. And you know that you want to give the server the opportunity to process this thing asynchronously. So you post your observation, you include an HTTP body with the new observation that you want to create, and then you include this header that says prefer respond async. And if the server is going to process this asynchronously, it responds with an accepted header, and it gives you a status location, just like in that bulk data use case. It says, here's where you can go to check on the status of your response. And then the client can poll against that URL to check on the status. And it might get a response that says, we're still working on it, retry after 30 seconds using a retry header. And eventually it'll get a response back. And that response, the design sketch here would be that response is always going to be a FHIR bundle with a type of batch response. And this is a little bit of a hack, but the idea here is that the FHIR bundle resource already is able to model HTTP responses. We have this FHIR data model called bundle.entry.response that can convey things like an HTTP status, certain HTTP headers like location, e-tag, last modified, and this can also convey operation outcomes, and it can also convey a response body, which is a resource. So maybe when the server accepts this observation, eventually it's going to assign some additional tags or otherwise decorate that resource. And so the idea here is by pretending as though a batch request has been made, the server can respond with a batch response bundle and convey a whole set of headers, as well as the resource involved or the resource body. And in this way, an arbitrary FHIR HTTP response can be conveyed asynchronously. That's the basic design sketch, but the requirements underlying this are really just, how do you kick off an arbitrary request and allow it to be processed asynchronously? And then when the request is finished, how do you successfully convey the various headers and bodies? And like I said, I think there's a number of ways to do this. I'd love to start some discussion about use cases and different alternatives, but this is more or less what I wanted to present today. And I hope this was clear. Happy to answer any questions about either the use case or the design sketch here. Or if we want, we could talk about queues with Nikolai for a little bit and then open up to just broader discussion.
Thank you, Josh. Maybe let's discuss this. So as we planned, this meetup should become discussion. So I have a question. So if we're talking about the bulk API, then usually client doing one thing, just exporting data or importing, yes. And it's kind of easy to manage this asynchronous response. If we're talking about when the client will do many requests, so it's becoming quite complicating how to manage all these asynchronous responses. So looks like yeah, the client becoming too complicated. If every operation will return this status location, then it's hard to imagine how this client can be implemented. So it has its own queue to go later and check all these statuses. So that's curious for me, probably this kind of half of solution.
Yes, I'm sorry, I totally agree. If you were doing lots of operations like this asynchronously all the time, that has many implications for how you would build a client. And I certainly wouldn't sell this as the best architectural pattern to be applied indiscriminately in all cases. My guess is that there may be just a few use cases where this kind of thing turns out to be helpful.
Because it looks like you're pushing problem from the server, because server could not handle it right now to the client.
Yes, I think that's well put, particularly for things that a server can't handle within the sort of time allowed for a synchronous HTTP response. And there's not like a hard bound on that number, but just practically speaking, how long is your connection going to stay alive? And what are the kinds of guarantees you want to make? Beyond a minute, you probably don't want to be in the business of keeping that connection open. Yeah,
that's true. But maybe that's going to be the next topic. I think the server can simplify this asynchronous interaction if it will provide some discovery of statuses, not just specific status, but let's say the search for statuses. So the client can go later and request all the statuses somehow, and then go through it. And this list of statuses will look like kind of queue.
Yeah, I think that's a great point. Even for bulk data exports, we've had some discussion about that, and some implementers that have implemented a task-based API, where basically they would say, we've got your export job, it's running, here's the status URL, but also we've created a task to track this. Yeah. And then clients can later search for their open tasks. So even if the client forgets the status URL and doesn't follow that whole protocol about checking over time, they could eventually do a task search and catch up on things.
Yeah, that's can simplify the client. So client just fire and send it. But it's still this pattern is problematic because you could not write some complicated logic. So you create one resource, you look into the response and making, I don't know, some if condition. So if something goes wrong, you're trying to fix, or I don't know, using some IDs from the server for the next resource. Yes, so the thing's still getting more complicated for non-trivial scenarios.
It looks like Nagarajan wrote a comment in the chat here around just that kind of approach with a status, lifecycle, and search. Seems like maybe some good early experience in that space.
Mm-hmm.
What do others think? Have people encountered use cases in this space where you wish you had a solution? Have people implemented or prototyped things that are adjacent to this?
Yeah.
Thank you, Josh.
Sorry, go ahead.
I had a quick question about, is there a way to specify what request, what attributes you want to retrieve on the resource? For example, if we implement machine learning models, if you want to have just the blood pressure data, is there a way to specify that?
I mean, in the context of a FHIR search, absolutely. When you search for observations, for example, you could say only certain link codes. For bulk export, we have an experimental feature, which is called type filters, I believe,
Filters, yeah.
where you can include search expressions and just pass those along. So you can say, I want all observations, but then here's 3 more specific search expressions. So only give me the observations that match one of these. And I'll say we have a little bit of implementation experience with those kinds of type filters, but a lot of servers have just said they wouldn't be able to support those in a performant way or wouldn't commit to it. So we labeled it as kind of an experimental feature. Nagarajan, I know you'd started to chime in as well.
Yeah. So what we ended up doing for the bulk export is we had a separate status or a task microservice, and then we end up, tracking down all these status, let's say like initiated at this time, and then processing, and then looking at all the lifecycle stages of the that particular export operation. And then we also track down the resources, which all the, like the URL IDs or the, key IDs of those resources, tracked it down in a separate microservice. But it became tedious when we started to, cover all the use cases like you mentioned. Therein we had to, come up with an approach for a pagination and, like go drill down a lot of stuff. But right now it's in a nascent stage, and then we are able to export patient or, like a resource of a patient, all the resources in an organization, they are up there, but then the search based on search, like export based on a particular search, I don't think we are gonna do that.
Interesting. And I see another comment in the chat from Tun asking about what about webhook callbacks? For sure, I think that's a really interesting area. I'll say that there's been, if we had something like a task search, we could start to talk about the use of FHIR subscriptions in getting a notification there. And I'm not sure, does this make things more complicated by layering subscriptions onto more and more capabilities? But, at least in theory, you could subscribe to updates in a set of tasks, and then you'd have access to the various different channel types that a server might support for subscription. So those include things like webhooks or WebSockets or goodness help us, there's been a strong community push for email-based notifications in some cases. Paul, I see you chimed in on the chat about LROs. That's long-running operations?
Yeah, same thing. Yeah, we actually have several. They're not, standardized, but this is like import, export, batch, de-identification. I think there's a couple other that apply to like DICOM and stuff like that. But yeah, it's a pretty common pattern.
And how do you look at maybe number one, is there value in standardizing these things? And if there is there value in doing that as like a generically anything can run as an LRO versus, standardizing each of those examples you mentioned in maybe a different pattern that best fits it?
I think there is value in standardizing them. I think we're basically on the right path, which is that there should be a core, sort of something part of the core spec that's like, here's how you get statuses, here's how you cancel things, here's how you, here's your general expectation for how you kick something off. And then have individual extended operations that are probably part of implementation guides for the specifics of, export or whatever. So yeah, I think we're on the right track there. Like everything that we've done that sort of, to some extent it has to fit into the Google Cloud architecture pattern. So there's some amount of difference just based on we're being common with our other products, not necessarily with, the FHIR spec. But basically everything that we've done as far as status and, task management, like operation management, is directly translatable to what's in the FHIR Async spec. Like it's just a matter of mapping, the fields that we have into the fields that you have. Like works pretty well. So I think we're definitely on the right path there in general. I would definitely like it if people did not kick off like hundreds or thousands of operations per minute. It's not helpful.
And I guess the client specified header is merely that they would prefer the operation to be processed asynchronously. Like, so for things that a server doesn't see fit to process that way, it's presumably at the server's discretion not to.
Yeah, that's a tricky one. So it's not entirely obvious that the client is really ready to receive a synchronous response, sort of dynamically.
Yeah,
I think that's asking a lot.
I agree.
I mean, my overall like 10,000 foot view of FHIR is that FHIR is a little bit too idealistic about how clever the clients are going to be. Like they're going to look at the capability statement and they're going to like make intelligent decisions based on the capability of the server. And like 99.9% of applications are not that clever. So I think when you give this sort of discretion to say, well, it could be this way, but it could be the other way, you're just making things difficult for developers. And probably you should be a little bit more opinionated.
Yeah, I agree with that very strongly. And it's interesting because something like the prefer header seems innocuous enough because it's kind of a standard HTTP pattern, but it really does suggest kind of a polite statement of preference rather than a directive. So I'm thinking, even if we wind up using the prefer header as the technical means of conveyance, we might want to have a stronger statement like, if you can't honor this preference, just reject the thing.
Yeah. I don't know my HTTP headers well enough, but I mean, accept maybe? Is that? Accept is stronger than prefer, I think.
It is, but I don't know. I mean, I don't know the HTTP standards well either. I've only ever seen accept used in the context of negotiating formats of response. But you may be quite right that, at least in theory, an accept header could be used for negotiating synchronicity of response.
Yeah, I think I responded on Zulip when we were talking about async for sort of CRUDS operations that honestly we've never really seen the value in it. Like even when people are spamming very large transaction bundles, I don't think we've ever really wanted to do them asynchronously. It's like if you it's sort of like at some point if you can't do it, you can't do it, and you have to push back on the client and give them 429s or whatever. And the client has to accept some responsibility for having some sort of back off, some sort of throttling or rate limiting, because like at the end of the day, there will be a bottleneck somewhere. And even if you're responding asynchronously, your server still has to have enough capacity to accept these requests as they're coming in and put them somewhere. And then like, have some queue that's actually manageable. And it does shift the problem, but it doesn't make the problem go away. So I don't think we've ever really seen the value in doing like a bundle or a search or whatever asynchronously.
Ray, I saw you made a comment in the chat. Do you want to share thoughts on that with the group?
I guess my thought would be that it's not really ready for prime time. If you're talking about the CMS DPC interface. I mean, it was interesting working with it because it was sort of the first practical application we had for bulk query. but the amount of plumbing and glue you have to put around it to make it useful, I think it's still, the version 2 promises to be considerably simpler to implement. And so I would, if anyone else is looking at it, I think I'd tell them wait for version 2.
And do you have a sense, Ray, about how much of that bumpy road was about just managing async stuff versus how much of it was sort of following the CMS group management and assertion that you sort of have to get in place before you can kick off a request?
Definitely, that was a big piece of it. You know, example of all the schooling you need to do queries of upcoming appointments for a specific provider group, and then figure out what the provider relationship is to those patients. And then you can upload that manifest to CMS, and then you get back some stuff.
Yes.
So one of the problems with the current interface is if they have an appointment with a patient, but they have no prior relationship with that patient at CMS, you don't get any data back, which is not a good design. So version 2 looks like it will fix that. The other problems are kind of what you've talked about, is it's asynchronous. You don't really know how long it's going to take on their side to get all the data back to you. And really the biggest problem with it right now is you don't just get some data back, you get everything they know about that patient. So like the encounters, it could be hundreds of encounters, past encounters. It could be hundreds of pads, med dispenses. So a lot of what we ended up doing in order to make the data useful was figuring out ways to filter what we got back, to throw out encounter types that we weren't interested in, and only look at the most recent meds and dedupe the meds, because it's Medicare Part D. Really anything older than 90 days is not even interesting, because they can't get refills longer than that. So I would just say it was an interesting learning experience, but and we do have it in production, and we're trying to put the clinically useful information together into in-basket messages and sending to the provider that has the appointment. But it's really still kind of experimental. We're just doing it for a couple of clinical specialties right now.
That's really interesting experience. And, you know, just reflecting on that for the group, I assume not everyone is familiar with this particular CMS offering, but a big piece of it is authorization logic. You know, what are you allowed to see? And so they have a pretty, I'll say, sophisticated, and somebody might hear that as complicated, approach in place to sort of figure out what is that list of patients that you're allowed to export data about. And you might be able to export data about a patient because you have a historical relationship with them. You might be able to export data because you've got an upcoming future relationship with them, or because you attest to having a relationship with them. There were like several different ways to kind of qualify. And all of that needs to be kind of set up and in place before you can begin the export on a group. So I can imagine where that would add considerable complexity to kind of work through all those procedures. On the other side, once you actually get the data, I'll say naively, I've always thought about the challenge of receiving more data than you want as kind of in the category of good problems to have. But I can see where if the ratio of data you want to data you got is low enough, even just managing that client side filtering can be difficult.
Well, you know, in our case, we're an Epic shop, so we have care everywhere. We have care equality. We have eHealth Exchange. So part of the job we need to do is filtering out data that we're already getting by other channels. There's a surprising amount of data that comes back from CMS that we would not have otherwise see, though. Just like little surgical centers and dialysis centers and urgent cares and things that really don't have a connection to us through those national networks. So it has been useful. But the amount of filtering you have to layer on your end to get the data down to something that isn't just a lot of noise. Adding a lot of noise is a lot of the work that you have to do.
Yeah. A note in the chat about managing transactions for bulk data updates. Do you just consider a single transaction and roll back, or manage partial failures? Yeah, I think this. So on the one hand, if we're talking about managing a single CRUD operation, I guess that's the trivial case where it fails, it fails. If you're managing a set of requests that was submitted as a batch bundle, I suppose we would say that batch handling semantics apply, and the queries that worked, and the ones that didn't. You do get into some ordering questions, so presumably those things shouldn't be interdependent. And if we're talking about a transaction type bundle, like if the original thing that a client submitted was a bundle with type transaction, then as you say, it would be all or nothing. All of that is really just restating what the FHIR HTTP API already says. In theory, for me at least, the semantics would be no different if you were processing those requests synchronously versus asynchronously. Only the timing would change.
Yeah, this is like,
what would your expectation be about? Would you be expected if someone issued, for instance, a query and it was being handled asynchronously, would you expect the results to have been current at the time it was issued, or at the time the response was created? Or just curious, obviously none of this is defined, but
I have a feeling that Paul's answer might address that.
well, I was actually going to go back to the earlier point, which is that this is why bulk import is a total nightmare, because like you've been given this bag of 100 million resources, right? And there are interdependencies between them. And you want to bring them in a state that validates referential integrity. And like some of them are going to fail because they don't validate against a profile or just not valid FHIR. So you're going to end up with this problem of managing this sort of unordered bag of input and trying to get it in a way that is consistent and has some sort of sensible thing that happens when inevitably some of it fails. And I think that's
an implementation that at least presumably you believe makes sensible and practical choices for import.
Yeah, the sensible and practical choices, you don't worry about any of that. You just bring it in. You're like, yep, bypass all the checks, bring it in. Because the advantage of doing that is that it puts the burden back on the client to say, if your data is fully internally consistent and all the references work out, then you can give it to our import method. And then at the end of the day, it'll look good. And if you didn't, then, well, it won't. But that's your problem. It's completely idempotent. Like if part of it fails, you can just like fix that part and just run the whole thing again, and it'll just slap everything on top again. So that is a solution, and it resonates with people to the extent that people are like, well, look, I have a bag of 100 million resources and I have to do something. It certainly does not solve the problem. It's just sort of like, well, this is a good V1. The documentation has strongly worded caveats about what it does and doesn't do, and buyer beware. I think on the sorry, what was Gino's?
I was just asking related that if you're you have concurrency issues if you're doing asynchronous things, for instance.
Yeah, this is the asynchronous on the query side. So the query side, this applies to export as well, which is very easy to make an export implementation that gives you an inconsistent data set because you got some of the resources and then you got some of the resources 5 minutes later. So we do this correctly. We actually read from everything at a timestamp. And we actually expose that timestamp somewhere. I forget the details off the top of my head, but I think from a client perspective, you're only guaranteed that the timestamp of the search or whatever will be somewhere between when you sent the request and when you got the response. And there's really you can't ask for more than that, right? And that's concurrency.
Yeah, and that's funny, Paul. So our initial implementation of bulk import was like yours. So we just skip all the validation, but then our customers still asking for consistency. So we go further. So we created kind of staging area. So we really loading all of these resources, doing the bulk validation, which is optimized for the bulk, like referential consistency and all this stuff. And if everything is okay, then we just kind of in transaction import everything. If something goes wrong, so we kind of create a special table with errors so people can go and introspect, even if it's again 1100 line in a specific file, so you still be able to see what's error. We still thinking should we just clear the staging area if there are some errors, or give some ability to fix it and proceed from this point, because you were waiting a couple of hours to load all of this data, then you have one error. What should happen?
Yeah, well, and the funny thing is that the flip side is that you have to be careful about error reporting if every single record has an error, right? Because there's a problem of like, what do you do about one error? But there's also the problem, what do you do about the 99% error rate, where you have an unmanageable number of errors? I think we actually truncate at some point. We're like, we'll just stop. We'll just stop logging errors. It's fine. You probably got your version wrong or your line delimiters wrong or something. But yeah, definitely unsolved problem.
Yeah, but another fix was, so we are doing bulk import without validation, but then we're giving a synchronous validate operation, which go through all of resources asynchronously, validated, and create again the special table with errors, so you can go watch and the problems and probably migrate your data in a database. So that's another solution. So you import without validation, but you provide asynchronous operation to validate all of your data. As well, this operation is very useful when you want to add the new profile, so you want to change the profile because you have existing data and you don't know, is it valid against your changed profile or not? So, and this is good sample for asynchronous operation, just for you.
I feel like
yeah, that's a great example. I'd love to have an asynchronous validate.
Especially when you're generating a lot of errors with that asynchronous validator, you should be able to just do some zero-shot classification of those errors, and then just, you don't have to return them all. Just say, we discovered this class of errors, and they are happening 93% of the time. That should be just a piece of cake.
Just return the corrected resources while you're at it, and just fix the problem, and there you go.
Yeah, we're creating the custom resource, so like a storing operation outcome. So, and you can search through it, probably group it, because we support SQL as well. So you can create some aggregating report of your errors and find the types of errors.
Well, should we talk about queues?
Oh, let's try. Okay, let me share my screen. Sorry for my audio, because I'm accidentally in a hotel and guys start singing here. That's terrible. Okay, I just want to share a few thoughts and go to discussion. So this is not a talk, not a presentation. So the first idea that FHIR naive CRUD is good for the server client, where the client has a short living session. So it's getting some snapshot of data from the server. I am doing something like rendering it to the user, modifying, interpreting, and then probably write it back. And the source of truth is your server. So this client may be your user interface or mobile application, and that works very well with the FHIR. But the more and more we see some scenarios when the people want to do the system-to-system integration. So let's say we have a kind of EHR which want to load your data into a clinical data repository. It can be several EHRs. So, and this problem looks like the data replication. So we have to replicate data from one system into another system. And the question how to do it. So essentially there should be two steps. So you have to get the initial snapshot of data and then start getting the changes. Ideally from the point when you get the snapshot. So potentially there are kind of what I see logically 3 patterns which can be applied. The one is a push pattern, so the source of data just pushing data to the destination. That's probably what the FHIR subscription do. Yes, so they pushing data to the subscriber. This is nice pattern, but it has a lot of problems. So probably we'll discuss it. Another is a pull pattern. So the idea that the source provides some kind of operation, so the destination can poll for the new data, for the changes. This is more flexible pattern. So but it has another problem. So for example, with a push, it's kind of quickly should deliver the changes from the source to destination. But it will have a performance problem if a lot of things happening on the source. So it will start bombing the destination. Yes, and I could not imagine the webhook, which is during the, for example, bulk import. So you have to send thousands of webhook calls to the destination in your subscription. You probably will just DDoS your destination. It will die. So as well, so sometimes the order has a matter, and I don't think, for example, with the webhooks you can guarantee the order of the messages. Yes, because it can be multi-threaded, and I don't know, you could not guarantee the order of the messages. And another real problem that what if the network was broken or the destination was redeployed? So then we have to have some retry mechanic, but which is really a challenge for the source. And if destination just died forever, so I don't know, some exponential timing or stuff like this, so it's getting more and more complicated. So with the pool changes, so you're losing this kind of time guarantees, but the control is moving to the destination. So destination is responsible to request data when they really need, when they're ready to get this data. So that's why, for example, in Natebox, we introduced what we call the changes API. It slightly changes history API with some additions, but so the destination can pull data from specific logical time. So and update it. Okay, there potentially can be the hybrid pattern, which solves the problem of kind of real-time replication. So that you do the notification to the destination that something changed, but you don't provide the data. And the destination is able to decide and go to the source and get this data, or maybe wait for some time and get a batch of the data. So this is 3 logical patterns. What I see, the potentially FHIR for system-to-system integration give us the bulk export plus subscriptions. I don't know how to handle the problem that the subscription should start from the point when the bulk ended. Yes, how to provide this, how to save us from this gap between when you do the initial export and then you do some subscription. Yes, and then we have a really problem about how we can guarantee the delivery and the order of the messages. But this approach may work. So we definitely have a lot of trade-offs, for example. So we can do, for example, the bulk replication much more efficiently and apply some bulk validation rules and stuff like this, and provide a good throughput, but the latency will be less. I don't know, everybody who read about the event sourcing and architecture like Kafka understand all of these trade-offs. So, and to start the discussion, I just want to ask the question, how, for example, databases do the replication, yes? And they usually use something like write-ahead log or just log, the queue. So the leader database, the master database, write the changes into the log, just append it. And then the replicas, it can be multiple replicas, reading changes from this log. So they have this contract so that the log, I think in the distributed system theory, the log is a essential model to replicate data between the systems. So it's almost the same what we call in the publish subscribe. Yes, so some producer write it into the queue. This queue ideally could be persistent, maybe persistent for some period of time, but day or months, because yeah, it's growing quickly. So sometimes you want to compact this queue, and there may be one or multiple consumers. So and yeah, and that's the start of discussion. So my question, what do you think about system-to-system replication? It can be FHIR system, or maybe not just FHIR system, from legacy to FHIR, and how to solve this problem. And can we introduce at least some patterns, or maybe even some specification to help people replicate data between the server? Because I think this, again, to this pattern of interaction emerging, and I think we have to answer a question, what the right way to do it.
So Nikolai, for this replication problem in particular, FHIR has the one operation, or one interaction, I should say, documented today, which is the history interaction, which is an ordered set of resource changes. Do you want to talk about where the limitations are there and where that pattern breaks down? Is it the wrong pattern, or just maybe the wrong data model
that
comes across?
Sounds very right, pattern.
Did you lose Nikolai?
Yeah, I think we did.
Let's just give him a minute. Maybe let me call him.
What?
Sorry, guys. Now they broke the it's a crazy house. Sorry. So I asked it about the history for all resources. Yes. And so, and yeah, probably the history for all resources, I would call it transaction log. So maybe the solution. I don't know, is anybody support the history for all resources? I don't know, Paul, do you support the history for all resources?
No, we never got around to it. Didn't have a lot of interest in it.
Yeah. So we support updated history. So we introduced what we call the transaction ID. This is a sequence which is growing when you're inserting resources, and it's a kind of logical time. So not that we're not using the since, because time kind of can be interpreted in different ways. So we introduced this logical time, and so you query this kind of history, what we call changes, and getting the new logical time to query the next time. So the client can save this previous transaction ID and request the changes from this point. Yeah. Another question that sometimes, I don't know what I see, that people want to at least slightly transform resources, like changing IDs, maybe inject some stuff in the meta of the resource, like source. If you're talking about for the central clinical data repository and multiple EHRs, or multiple systems sending resources to that central place.
Yeah, I think there's a really important point there, which I think is relevant to import as well, which is like you're aggregating data from multiple sources and you want to remap the IDs. If you can, obviously, if you can avoid remapping the IDs, then you sidestep all this. But I think we might need some sort of common pattern, whether it's using meta.source or I don't know what, could be something else, to have a pattern of like, this is the ID in the system that it came from, and then have some sort of principled way of like tracking how you mapped things, or at least putting an index on, basically on meta.source to say, so you can find these things and deduplicate them when you're getting incremental updates.
So having consistent patterns or practices there makes a lot of sense to me, but I couldn't tell, Nikolai, in your suggestion, was the idea that when you're replicating from a source to a destination, would the source system need to know about those patterns and sort of pre-populate bits, or is that something the destination would manage kind of once it grabbed the next chunk of data off of the queue?
Yeah, that's still open, the question. Somebody will implement this pattern from one side or from other side. Yes, even if we're talking about subscription, the hidden queue behind subscription, yes, to try to deliver and all this stuff. Or if you're polling some mechanic on the client side, how to save the state and all this stuff, how to process this data. So I'm just trying to make it kind of explicit and discuss how this can be done, because I see a lot of people struggle about this. So they're trying to find solution. So for IDs, so what, for example, we go against the FHIR with 8box, so we potentially provide the user ability to manage IDs, because this really simplify something like bulk import, so they don't have to remap. If, for example, they have few hits or something like this, so why should I map it again? Yes, and another simple solution may be just prefix the IDs from specific source and kind of say this prefix only for this source. Because otherwise you have to remap all the references. Yeah, it's a huge amount of work to go through all the references and remap the IDs and keep this mapping table. So
yeah,
probably the global ID and using unique IDs would be the solution for that.
So yeah, I mean, now we get into levels of control on the source systems. So yes, if you could go back in time and cause all the source systems to generate good UUIDs for everything, the problem of remapping becomes much simpler. If you can't do that, the challenge with prefixing is stuff gets too long, particularly as it moves from hop to hop. FHIR has a hard cap, right? I think 64 characters on the length of an ID. And the prefixing strategy dies pretty quickly there.
Yeah, then we're gonna work like with the byte protocols. Yeah, this first 8 bytes dedicated for the prefix, and you have to reserve your specific your magic number before you importing.
Well, we've come across some implementations that solve this problem by just using IDs that are too long to be valid, which is one approach.
Yeah, but I think with the with adoption of FHIR, this question will rise again and again. Yes, because so now we have interoperable data, and the data start moving from one system to another system, and people want to aggregate it from different systems. Probably introduce a unique ID for the resource as a solution, just global unique ID. So every resource will be unique. So even if you move it between like through the several system, so it will keep this ID forever.
Yeah, my typical fallback for that has just been to take a SHA-256 hash of the full URI that it originated from, which helps you if you want to be consistent in making that calculation again, but does not help you if you need to go backwards.
Nikolai, because I don't know if you have chat still if you disconnected and reconnected. Just a couple of notes that had happened on there while you were talking is that subscriptions does have batching built in. So you can say, I'm just sending one notification with the 1,000 events per second or whatever it is, so that you don't DDoS your server, the endpoint. And then also there's now an operation, it's still optional, but defined so that you can go back and query for previous events, so that if you are worried about them missing or replaying them or different things like that, there's a framework in place for how to do that standard way.
Well, thank you. That sounds very great. And in case, so the subscription can deliver the message with multiple events, yes? So you're aggregating,
yes.
So, okay.
Yes.
Thank you. Yeah.
And yeah, if there's things like that that come up that would be useful, please feel free to chime in, since we still have a little time before R4B and plenty of time before R5 is published.
Thank you. Any plans to introduce in subscription some kind of queue destination, not just email, like I don't know, Kafka, some cloud queue. So
Yeah, we have defined that you can set up custom channels, and so that's one of the things that so far I haven't actually defined any of them. We haven't found one that says we can meet the 80% that it's worth defining in part of the core spec. But we have tested things like I made a Zulip channel just to see if the custom definitions work, and it all works well. And it should be pretty straightforward to set up with your queue of choice, message queue of choice, cloud internal protocol of choice, etc. With just a couple of custom extensions if you need secrets or configuration things attached to the subscription. So.
And any integration of subscription with the initial bulk export. So
they're not to my knowledge. What would you picture something like that looking like?
Things like if you're exposing a task as a wrapper on the export and people want to learn when it's done, getting a proactive notification on that would be pretty simple.
Yeah, so one of the other things we've added to R4B, the R5 hasn't been synced up yet just because we're furiously trying to finish everything in time for R4B publication, is in addition to resource triggers, we have event triggers. So you can easily define an event such as bulk export completed or bulk export change state or something like that, so that you could trigger off those and send notifications. And our guidance there has been to use a parameters resource to send that information to a client, so that you can link to internal data, external data, or just arbitrary fields that you want to send to the client's endpoints.
That might actually be a fun concept to mock up, just to say like what, for a client that wanted to subscribe to a set of these, you know, either filter based on the IDs of the different jobs that we're running, or just get a stream of all the notification events. So that'd be kind of fun to play through.
Yeah, I'll put it in a note to write it up and see what it looks like.
I even had another crazy idea. So maybe you know how the Postgres replicated. So there's a way of warm replication when the Postgres just do the batches of this write-ahead log. They call it wall logs. And then you can distribute these wall logs. And these wall logs are numbered like 1, 2, 3 with the sequence numbers. So there's somebody who is replicating just searching for the next wall log. So we can publish such wall log for the FHIR in NDJSON. And then you can put it in, I don't know, S3-like bucket, and everybody will be able to get all of this data. So in Postgres, you have a kind of base backup. So it's getting the snapshot of the database, and then you can reply these wall logs and get to the point.
Yeah, I think there's the execute history bundle support that got added in R4 is interesting for this. I don't think it addresses some of the points that it needs to address. But this idea of like, we should have something that's like a change log that probably looks like a history bundle, or maybe, you know, maybe each file is a big history bundle or something like that. I think there's some patterns that have to be figured out as far as how do you ingest that. Because like, okay, you're bringing in these versions, presumably you're like making them appear to have come from the timestamp when they happened, not when you're bringing them, not when you're replicating them. And then it's like, well, but what if your history ends up getting interleaved with mutations on the replica? Because maybe your replica isn't a replica, maybe it's like somebody else's system and you're sending the data over. So there's some weird cases you can get into where you can end up with what appears to be an invalid history of, you know, there was a delete and then there was like, you know, a create, and there was a delete of something that didn't exist. So I think there's some details there that are not easy to work out. And the language that got added to R4 is sort of like, well, it's a starting point, but doesn't really settle some of the details you're going to need to contend with in order to actually ingest these kind of change streams. Oh yeah, one other thing closely related actually is it's actually been a relatively common feature request that we've seen at Google for, I want to do an export and I want to export all the history as well. Like I just want to back up the whole thing, change history and all. And it's actually, the interesting thing is first, how do you structure the export? Is it one history bundle per resource? Like, is it one file per resource? Like, is it NDJSON where each line is one resource? How do you tell the difference between, like, is it different if the resource is currently deleted? Like, are you exporting the current versions and then exporting the history, or are you exporting sort of the current versions plus the history? In which case the deleted ones are kind of different than the ones that exist. And then step two is like, how do you read that back in? Like, how do you do an import for that history? So I think there might be some value in standardizing some part of that. Because if we settle on different conventions, it could become very, very awkward.
Yeah.
That problem's, oh, sorry, go ahead, Gino.
Oh, I was going to say the same. Yeah, it's actually gets very scary too in some of the things we were talking about. For instance, why was it deleted? If it was deleted because it was entered in error, or if there's a new security thing that you're not allowed to see, then do you still send the original before it was tagged? Do you still send the original before it was deleted? There's lots of kind of delicate corner cases that come up in a lot of those situations.
Yeah, I think that that's out of scope for what it's at least out of scope for the use cases that I'm worrying about. Like, I'm worrying about cases where it's the organization server, they own everything in it, and they're just making decisions at that level. Mm-hmm. They're not really making those kind of decisions about, is this data, are we supposed to have this data? Are we not supposed to have this data? There are other means that they would use to purge that history. Like we have a purge operation. It's like, I guess Happy went with expunge, we went with purge. So maybe we should standardize what standardization is for.
There's a ticket for it.
Yeah, so we should standardize on our delete the history operation. But regardless, I think that, if you try to, you can't try to do too much. And I think if you start going down that path of trying to figure out whether you should export things, it's more valuable to just have something that actually exports everything, which will address the use cases of the people who own everything. And then we can worry about how to limit that, down to narrower use cases. But I mean, in one is application design, right? If it's entered in error, you shouldn't delete it. You should change its status to entered in error, right? That's a convention. And if you're tagging something as you can't look at this, ideally, in theory, you should be tagging all of the historical versions, right? That is how FHIR supposedly works. Whether or not people implement that, it's asking a lot, but yeah.
So, I mean, even for that purely mechanical challenge, not worrying about the policies around it, but just how do you convey that history of versions? You stated that problem, Paul, in the context of something like a bulk export, as though it was sort of something that Nikolai's problem made you think of. But they almost seem like identical to me. Nikolai was talking about how do you get one server to replicate the complete set of changes so that somebody later can reproduce them. Do you see a distinction between the two problem statements?
I think that they're connected, but I think that batch and streaming always have different considerations. And you always end up with some sort of batch case that is intended to just take a snapshot and do it efficiently over a very large amount of data. And then streaming, which has concerns like sort of latency and ordering and things like that are not a factor in the batch case. And then you have a cutover between the two, which is, super fun to design around. So I do see them as like closely related but distinct.
Yeah, I think so. We even sometimes we were thinking about defining the whole dump of the FHIR server on a file system. So some folders, I don't know, resource type, the history files, and potentially this is looks like bulk export, but for everything. So the whole server can be dumped and then restored, and maybe the structure of this dump may be the subject of the specification. So then you will be able just to dump everything onto the file system.
Yeah, I think we're sort of 95% of the way there, because we have a very stable, like, everybody understands NDJSON FHIR. It's just a matter of, everyone understands bundles, everyone understands what a history bundle is. We just need to work out some of these corner cases, like, you know, is the current version out of the history bundle or in the history bundle, like those kind of things. And if we could, I don't know what the right venue is to even standardize that, maybe in the bulk export IG, maybe somewhere else. But I think that if we sort of get to that consistency before it's widely implemented, we can really head off any potential problems and make it. Because right now, like, my import method will happily take anybody's export data, and hopefully vice versa. You know, it's, yeah, we've got a fair amount of consistency. We just need to not lose it.
So on that subject, I mean, this feels like it would be worth pushing on pretty quickly and seeing if there's like any deeply surprising challenges. I'm thinking about, you know, the various building blocks that you mentioned, things like history bundles, things like new line delimited JSON, and, you know, how we combine those. I'm wondering whether you think the current history interaction as it's defined, we've said, wow, there hasn't been a lot of demand for it. It's maybe too general a thing. It doesn't have logical timestamps, but it does support one mode of operation, which is paginated fetch of the most recent end things that happen on the server, and then you can just go to the next page and go to the next page until the beginning of time. In theory, I'm wondering if anyone has looked at it closely enough to know, like, if you did call that and drain it all the way to the end of its history, would that have all the data we needed for this use case? And if so, we can think about using some of those building blocks to put together maybe a more efficient batch strategy. It's just one concept, but I don't know. I haven't looked at the history interaction or the specifics of whether it names the previous version that each new version overwrites, or those kinds of details to know whether they're present.
Yeah, that's curious, because I have some critique of the search response and the history response. It's not streaming friendly. So, and I once wrote in a Zoom chat that it would be nice, as you talking about generalized async operations. So probably we should generalize something like NDJSON format for the search and for the history, so the server can stream this data instead of sending the huge JSON file, which is hard to process in a stream. So the most of parsers, maybe there are some streaming JSON parsers, but I never heard about this. So if you, for example, if you want to return a lot of data in the search or in the history, so potentially you can stream in even gigabytes from the server. Yes, it can be implemented, but not with a bundle, not in a bundle.
I think that's an excellent idea. I would like to see that.
And just to put a finer point on that, the idea that you have there is not to go through this intermediate route where there's a manifest that then points to the NDJSON files, but just say you write your query and then synchronously and in a streaming fashion, you're getting back, you know, lists of entries.
Yeah.
So some of the challenges there right out the gate have to do with what about the rest of the metadata from the bundle? You know, where should we stick it? And I think these are totally manageable, right? Maybe the first line of the NDJSON file is a bundle that has no entries, and the entries are to follow. Those kinds of things could be worked out.
And we did kind of sample implementation, which are not FHIR, but you can really stream gigabytes through the database. So it's implementable, and it works for the bulk scenarios as well.
I'm surprised, Nikolai, that you haven't written a streaming JSON parser that can process large FHIR bundles. I mean, I haven't either, but I just sort of assumed that of course,
it's a pain in the neck. It's a pain in the neck. The out of order things, you have to reconstruct the stream because you might not even know the resource type until, for instance, the last element of what you've parsed. And so I have written one, and it's not pleasant. So
to go back to one of the complaints about the history interaction. So basically, the fundamental problem with it is that if you have to page through them in sequence, you can't parallelize anything. You have to just go through the pages, and there could be an unmanageable number of them. That's like really the biggest complaint. Like, why is this useful? Well, it's useful as long as the history isn't too long, or at least the part of the history that you're looking at isn't too long. But like with bulk export, you can get gigabytes back, you can get terabytes back. Like, it's not a huge deal. We know how to parallelize jobs that read data and write data. It's just, history is like, it's the same thing with search. Like, sure, you could, in theory, get all the resources in the store by doing a search with no parameters, right? But is anyone actually going to do that? It's pretty problematic.
Yeah, and I wasn't trying to suggest that we would use the history operation for this purpose at scale. I was more wondering about whether the data modeling that exists in those history bundles and the idea of having a sequence of them that you acquired somehow, whether that has all the data and the properties we would need to sort of capture that batch export result, or whether there's actually something's missing, and maybe nobody's looked at it.
Yeah. So yeah, the important point there is actually that there's one other specific design decision that I didn't mention, which is are the history versions for a particular resource collated together or not? And in the history output, they are not. You're getting a stream of just all the changes on the server. So you have to go, if whatever you're doing with it depends on being able to assemble the history for a particular resource, you have to go through and find it, which could be very difficult.
Worse than that, because you can only page backwards. So you get a series of updates on top of things you don't have yet.
Yeah,
and
so you got
to go to the end and then replay it forwards.
Yeah, so that is basically sort of implicitly making this decision that you're not going to collate, and that is probably not the right decision. It might be, like, you can make it work, but I would probably lean towards collating as being more helpful.
So like one, okay. So if you, in other words, when you say collate, you mean all the changes to one resource, you're definitely going to get in the same chunk or file, or ordered and together. At worst,
they're contiguous, so they might be split across like a shard boundary or something, but they are at least like, if you were iterating through, they'd be all in the same sequence.
And the shards are ordered such that you don't have to worry about which set.
The shards are ordered such that you can find that.
Because the one thing I think we don't have today in our bundle, like in our history bundles, is a way to say what version of the resource this change has been written on. I think it's just implicit that it's the most recent version. And so you wouldn't have a way to even process them if you couldn't guarantee that collation. It would be perfectly plausible to just include the previous resource in there somewhere, but I'm not sure it really helps if all the practical strategies require the server to collate anyway.
You can just sort by meta.last updated.
You can.
That's how you do it.
If you're sure you have them all, then you can. If you're getting them streamed in various chunks out of order,
then you don't know. Yeah, then you don't know.
Yeah, on that same token, I guess we should file a ticket for that one. The history operation talks about how a put or a post shall contain a resource, but is silent on patch. And I assume in a history, if someone did a patch, you would want that to include the resource as well.
Yeah, I think eventually FHIR will come to CRDT type of stuff. Yeah, because so initially we just talking about replication, but in the future these resources will be modified. So you will get these conflicts and you want to resolve them. And ideally you should send the patches, so the changes. So at least this will reduce the number of conflicts. And
So this is hard, right? Like FHIR is built around linear history right now. Changing it is tough, but I agree with you. There's an interesting point there. I think for all the use cases we've been talking about, I had assumed that if I could somehow do a batch export of my whole system history, I was assuming that the entries in that thing would be agnostic to whether they had come from a patch versus a put, for example, and it would just be like, here's a state of a resource, or here's how to compute the state of the resource. But I wouldn't necessarily be exposing the fact that this state came about because the person submitted a patch.
Well, the deletes look different. You can
They
tell,
do.
you can tell which one's a delete.
That's true.
Yeah.
And maybe it is worth being faithful, like taking as a design constraint up front, the ability to convey fuller semantics about what was submitted. I mean, so for example, in FHIR, servers are allowed to do arbitrary stuff between receiving a request and applying it. So I got your post of payload X, I modified it to be payload Y, and then I persisted Y. When you're exposing your server state, the full history, is it relevant and interesting to share the fact that X was submitted at the time that Y was created? I would tend to leave that out of scope, but I could see somebody might want it for something.
Yeah, my hot take is no, I would leave it out of scope. I would just record what you actually stored, I think. Because if what you want is to figure out the difference between X and Y, and if that's important to you, I would probably like log the requests somewhere else rather than in the change history, because it's not really germane to the change history.
So I agree with you, but I think having clarity on that question also leads me to think conveying the difference between something that happened because of a patch versus a put shouldn't be relevant either.
Yeah, I don't care. I don't think. Probably not.
This feels like a fun and tractable design problem. Is anybody like actively planning to write something up on this subject? Okay.
I'm probably just going to implement it. I'm going to implement history export just because customers are going to get on my case if I don't. But yeah,
please you write up how it works when you do it?
Yeah, no, it'll be. I'll figure out what our take is. I mean, there's all these design points, and I think I have a design doc somewhere that lays out the potential decisions but doesn't make the decisions. So we'll have to get to that point, and I'll tell you what we came up with.
Cool.
Okay, any other ideas to discuss or questions? Hey guys, join the discussion. You can ask any question.
Yeah, shy. So with real EHRs like Cerner, Epic, that most of the hospitals I've seen and pharmacies running up to the limit. They don't like anybody querying them, putting extra load on the system. So something that generates FHIR compatible export would be useful rather than waiting, for Epic to increase the limit for more than 1,000. Or like, can we combine? It doesn't have to be API. It's a data kind of format and the API. But I'll gladly take batch as long as it's a good format, because I understand FHIR schema, but I don't understand Epic schema. What do you think? Would it be useful to modify Paul's code to export from Epic or Cerner?
I mean, I think the question there is always just access path to the data, right? Like code is running somewhere and generating some load on that database server. And so, often strategies involve using shadow databases or a copy that lags behind production by a day or by some interval of time. Those are the kinds of things that kind of practically can help alleviate some of that load.
So instead
we call it caching FHIR facet. So you're just setting up the FHIR server, replicating data from, let's say Epic through the HL7 v2 to this FHIR server, and then you get more data than Epic FHIR provides.
Nicole, we can hear you.
Yeah. Sorry, Daniel, I interrupted you. So you're trying to say something.
No, I just finished. It was a question. So I like the idea of export, but it doesn't have to be from FHIR server. Any legacy server would help. So because these models are secret sauce of the vendors, so they're hard to get to. And
so you mean that not even FHIR system can do the FHIR export?
No, it can, but they're afraid of somebody opening API to ask to query. So they put interface engine or kind of methods because somebody's coming to them. But if it's a push, they have their batch loads. They know at night, I take their NDJSON export in the morning. I don't care.
Yeah.
So rather than coupling it with REST API and Epic telling me, do not ask more than 1,000, they can give me the file in FHIR format as a batch that I can ingest.
So, I mean, one of the new requirements that's coming out in the US certification landscape is for this concept of electronic health information export, EHI export. It doesn't come online until the end of 2023, and it doesn't require the use of any particular standards, but it provides a way for a health system to kick off an export job for all of the data, whether it's part of the US core data set or not, just everything that the EHR manages about patients. And the interesting thing about that requirement is even though it doesn't use standard formats or it doesn't require standard formats, the documentation for those data, how to use them, how to read them, what do the fields mean, that documentation needs to be publicly accessible. So that's outside of the realm of secret sauce. So it'll be interesting to see kind of how usable those sorts of exports are as they start to come on the market. My guess is that people will invest considerable time and effort in mapping those kinds of things into FHIR or other standardized data schema. And those mappings are going to be difficult to maintain and painful because the data will be highly variable, but I think there will be motivated parties who will put in that effort by reading the docs and testing and keeping things up to date. So that's one bright spot that might help with some of those use cases, but it's also a little bit down the line.
Thank you.
Okay, guys, any other questions? So we have like 15 minutes. Don't hesitate to ask. Oh, that's enough for everybody. Yeah, and I like so much this format. I don't know. So this discussion format is much more valuable than just having one talk pushing ideas. So if you have any other interesting topics for the next meetups, yeah, please contact the Pavel and let's organize it.
Yeah, thanks so much for everybody speaking, attending. Was a pleasure having you all, and especially thanks for who contributed, Josh, Nikolai, Paul. Thanks so much.
Thank you all.
Thank you.
Yeah, thanks.
Yeah.
This has been fun.
Thank you.
Thank you, Pavel, for inviting me.
Yeah, guys, have a good day, night. See you next meetup. Bye.
Bye, everyone.
Cheers.